Hello everybody. In this video we are going to look at top-down parsing. So top-down parsing is already discussed. It constructs a parse tree starting with the start symbol and going down to the leaf nodes. And it is nothing but the leftmost derivation for an input string. Now in top-down parsing, at every step of the derivation process, we have to determine which production is to be applied. So suppose I have a production like this, say x1, x2 or x2, x3 like this. I have multiple choices. So now if I have to expand A, so the question is now which of these two production should be applied. So to determine this, there are different ways. And this is determined by your type of top-down parsing that you're going to use. So top-down parsing can be classified into broad categories like this, like top-down parsing can be broadly classified into two categories. One is top-down parsing with backtracking. And other is top-down parsing without backtracking. So this is also known as predictive parsing. So without backtracking, we have again two categories. One is your recursive descent parsing without backtracking, and the other one is known as LL parsing. So what is the difference between these different categories? So let us start with our backtracking parsing. So backtracking means that I have to come back. If I don't find a match, then I have to come back to a particular point and try again. Let's see what it means. Suppose you are here and you are trying to find your friend's house. And there are all these different number of lanes. Okay, you are at this junction, and all these are different lanes in your in a particular locality. Now your friend's house is located somewhere in one of the, say it is located here. Now you want to find out. You don't know where it is. So first what you do is you try the first lane, go this side, reach the end. If you do not find, come back to this point. Then you try another lane. Okay, is it here? No. Then come back. So what you're doing basically is you are searching each of the lanes in a particular order. Say this is 1, this is 2, this is 3, this is 4, and so on. And then when you don't find, you reach a dead end, what do? You come back to the original position. Okay, so this is known as your backtracking. So you'll continue this till you find a match. And if you don't find a match at all, in that case, that means that you are in the wrong junction. Okay, so your backtracking algorithms, parsing algorithms works in this manner. So when you have a choice, suppose I have, like I said, x1, x2, x2, x3, x4, x5, something like this. I have multiple choices of these productions, A production. And I have to, some point in my parse tree, I have to expand A. Now, which of these productions is to be used? When you don't know, then you try out in a particular order. All the productions in a particular order. So, suppose you try out the first one here. If it does not match, then you come back. You try again with 2. So, if 2 also doesn't match, then you try with 3. and so on. So this type of parsers are known as backtracking parsers. Now backtracking parsers are very powerful again, but they are slow and they require exponential time. So they require exponential time. So imagine writing a compiler which requires exponential time just to compile your program. So it is not very practical. So backtracking parsers are not so practical. So we are not going to discuss these in details. Okay, so that is your backtracking parsers. The other type of parsers, which are called predictive parsers, these do not use backtracking. Okay, they do not use backtracking. So if they do not use backtracking, then how do they know which of the production is to be applied? So they do so by looking at the inputs, how they predict. That's why they're called predictive, because they do some prediction. And how this prediction is done? It is done based on, this prediction is based on looking at some input symbols. So you look at few of the next input symbols that is there in your input string, and then based on what you see, you make the prediction. So if you look at k characters, k input symbols, then this is known as your look ahead, k look ahead. So usually in most programming languages, if you look at just the next symbol, if you use one single look ahead symbol, that is good enough. Okay, so predictive parsing or predictive parsers make a decision as to which production is to be applied by looking at the next character or the next k characters in the input. So this the class of grammar for which we create these predictive parsers using, say, k. This is sometimes it is also known as LK grammar. We'll discuss more about this in the next few classes. Grammar. So in here also we have, in predictive parsings also, you can see I have mentioned here that there are two types. One is recursive parsers and the non-recursive parsers. In recursive parsers, that means it uses some kind of recursion. Okay, and LL parsing does not use any recursion. That's the difference between the two. Okay, both uses look ahead. Both recursive descent or LL parsing, that is all predictive parsers, use look ahead. How many look ahead is used? That can differ. Okay, but remember, this uses recursion, this does not use recursion. So it uses a table whereby you look at the parsing table and then you can look at the input symbol, and then you can decide which production is to be applied. So that is your top-down parsing in brief. In the next video, we'll discuss about recursive descent parsing.